looks like this. We need to cover it with truss for this area and the frame for the other area at the same time. This span equal 120 feet. 120 feet, 2B, and B equals 60 feet. And for this span, your frame span is B, which is 60 feet. So your trusses will be like this, 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 and this. And your frame like this, and this, and this. Your spacing is given. I need here 6 spacing. I need here 4 spacing. And each spacing equal 20 feet. I need to design every single part in this group. Group number 2, we have another area with need to be covered. Don't to print anymore. Don't print. We will not write anything, just to watch on. We have another area. We need to cover it with frame, truss, and frame. Your main system is different a little bit today for this group. Your main system is a combination between 2 structures in one structure. Truss and frame at the same time. This column serving for truss at the same time for frame also. So your main system consists of truss and frame at the same time. Your total span 3B. We have here 2B, half B, and half B, so the total span is 3B. Will be spaced for 7 spacing, each spacing equal 25 feet. Second group. Third group, we have another area which will be covered by truss in this span. Here is the span of your main system for 4 spacing. And here is frame covering, but your frame had 3 columns. Doesn't matter, you will solve everything using reason. We don't care about what is the shape of your main system. But anyway, the fourth group we have area looks like L shape. This one or this little area will be covered by truss only. The remaining area, this one and this one, will be covered with another main system which is combined between truss and the frame at the same time. Your truss will be here and the remaining part of your frame will be here. First step, we need to draw layout. Plan, elevation, side view. Your side view is given. Or you need to add some side girds and end gable. But we need to draw what is the plan, what is the elevation for each main system, for each project. So please, by the end of the day, tell me the names of each group. I need 4 groups. Okay, Hunter and David will not be in the same group. Okay? Before starting, I would like to share something with you. Sometimes you have a beam and you have only uniform distributed load. Sometimes your total distance of this beam may be 60 feet. Can you remind me what is the shear force diagram? What is the bending moment diagram? Your shear force diagram, something looks like this. This point at mid span with this value will equal this one because your reaction here will be the same like reaction here. Anyway, your bending moment diagram will be something like this. Your maximum value will be here at the point of zero shear, WL square over 8. Do you have any question? Okay, your beam is wide shape. Looks like this. From the manufacturer, we have standard lengths of your beam. I cannot get beam with 100 feet. How can I made it? How can I make it? How can I transport it? Actually, your standard length from any manufacturer, I think, for beams around 30 feet. The standard length from the manufacturer will be beams of wide shape or W shape for any cross section, as you like. But our standard length is 30 feet only. That means if you would like to construct a beam with 60 feet, what should I do? I will use two beams, each one 30 feet will be connected together at a certain point. That's right? So I will have beam with 30 feet, another beam with 30 feet to be supported here, supported here. That means I need kind of connection between these two parts of your beam. The available length from the manufacturer for this shape, only 30 feet. We cannot make with lenses equal 60 feet or 70 or 100. Anyway, so I need a kind of connection in between. So right now we have beam, two, beam, connection. That's right? I have question. At this point, what do you have from internal forces? From shear force diagram, from bending moment diagram. What do you have?
Shear.
We have shear equal 0. We have moment equal some value. That's right? So I need, I'm trying to create your problem. I need to design a connection, beam to beam connection to support zero shear force and a value of bending moment. That's right? Maybe your length of your beam something like 75 feet. So what will be the scenario? The scenario will be we have 30 feet, another 30 feet, and another 15 feet. That's right? So we have two connections, one here and one here. At this time, I think we have a value of shear. We have another value of moment. We need to design. And the same here also. We have another value for shear for this connection and another value for moment. That's right? Sometimes your connection will be under effect of shear only and your moment equals 0. Sometimes your connection will be under the effect of moment only and your shear equals 0. Sometimes your connection will be under the effect of moment and shear, based on what is the diagram of your internal forces and where is your connection. Maybe your connection at point you have 0 shear. Maybe your connection at point has 0 moment. Maybe your connection at value of shear and moment. Do you agree? So we have different scenario for your connection. Also, for column, your frame something like this. Maybe your height of this column 50 feet. I don't have length of a column equal 50 feet. The standard length 30 feet most of the time. So I need to do a connection between 30 feet and another 20 feet. Okay, go ahead and draw your internal forces. For this frame, we have shear, maybe something like this, and we have moment. So where is your connection? If you try to say, hey, here is the 30 feet, and here is the 20 feet, I will have connection at this point. What do you think for this connection? This connection will support shear equal to this value, and moment equal to this value. That's right? So based on where is your connection, maybe also your frame will have fixed support here. So your bending moment will be something like this. So I will try to do my connection at this point. If you did your connection at this point only, so we have moment equal 0, we have shear equal value. So this connection can be called column to column connection. Maybe you have shear only, maybe you have moment only, maybe you have both of them based on what is the diagram of your internal forces. Any question? Okay, let's start with the first type of connection, beam to beam connection. Here is the connection. We have a beam and another beam connected together at this location. But this beam only beam to beam shear splice connection, shear connection. This type of connection will support only shear value. If you have shear value only and your moment equals 0, then your connection will be one plate. This plate connected between this beam and this beam, and you have two columns of bolts. One, the first column supported this beam, the second column will support this beam. That's it. This shape of connection only for shear. Do you remember when we covered shear? Anybody remember which part of your cross section will support your shear? Web. Web. If you remember your design shear strength based on 0.6 F yield area web. So I will try to connect this web by this plate. You got it? So this connection, no connection between this flange and this flange, this flange and this flange. That means this shape of connection only will support shear force. You got it?
So that means moment equals 0?
Yes. Maybe for any reason, because I'm doing very simple beam, but sometimes your beam has a moment something like this. So at this point we have moment equals 0. Okay, so based on your internal forces, I will decide this connection will support shear or moment or both of them. Any question? We can build this connection using RISA connection, and the program can tell us if your connection failed or passed, safe or unsafe. Based on, for this one, I can choose what is the left cross section beam from this one, your component of your connection. Left beam section, you can select what is the cross section of your beam. In this case, it's W 16 times 36. What is the cross section of your right beam? And also, you can figure out what are the dimension of your plate. This plate, you can figure it out. What is the width? What is the thickness of your plate? Also, you can figure out what are the left beam with bolts. What are the bolts here? You can figure out what is the diameter of your bolt, what is the type of bolt, what is the group, and also you can figure out the properties for the right bolts and the number also. You can try until you got something here called tell you that this connection is. One more thing, yeah, loading. According to LRFD, so you need to multiply dead load by 1.2, life load by 1.6. What is the shear force? What is the axial force? Maybe we have axial force, but we don't care more about axial force. Our concern, this connection will support a shear force. From your shear force diagram, I can figure out what is the value of shear force. So, also, beam web connection. You can figure out what is the type of your connection. Maybe your connection is bolted connection, maybe it's welded connection. Let's see. If I open the software, that's smart, she's smart.
How old?
2.5. So, I open it. Here is the main window for the RISA connection. It's demo version, okay? You can choose your unit. What are your unit? Kips, feet, inch, whatever. You can choose setting to enter the information of your project, or you can use this. You can put your information here. What is the name of your company? What is the name of the designer? And what is the job number? Anyway,